So the volume of the object in this case would be equal to the volume of the fluid. And again, this is an example where it's completely submerged on the bottom of the ocean, on the bottom of some body of water. So if we want to figure out what VF is, we have to utilize VF. It turns out that it's going to be the same thing as this VO here. Remember, when an object is fully submerged, VO is equal to VF, because the amount of water pushed aside is the actual volume of the object itself. From that, we need to subtract the force of gravity, which is m times g. And that's going to equal our apparent weight. Our apparent weight. How do I find the mass of the object, though? It's not given. The mass of the object is not given. What do we learn in this chapter that we could replace mass with whenever we feel like it? There's an expression we can use to replace mass. What is it? Good. Remember, and Dirk remembers from his formula, you can replace mass with volume of the object times the density of the object. And the other part carries down. So it all carries down continuously. All right. As a result, all we have to do is plug in. Some of you calculated the mass of the object, I do a rho v, and calculated the mass of the fluid, and said the difference in the mass would be apparent weight. That's like the apparent mass, really. Very different things. Now, the force itself is what's keeping this object from going through the actual ground. That's the normal force pushing back up, which is really the apparent weight of the object itself. So, if we look at this, we can simply factor some stuff out. What can we do to take out to make it easier? Instead of multiplying this a few times. Yeah, V is the same for both. The volume is the same for both of these. What else? G. So really, it's just a difference in the densities. And we came up with this conclusion in class. All right, some of you may have remembered that. That's the general conclusion. The volume times gravity times the difference in densities is what provides us with a difference in the forces. And therefore, we have an actual apparent weight. And you can calculate, it doesn't really matter what it comes out to be. Okay, yeah, we're going to get a negative answer. The weight is acting down, so we have our negative Fg. The weight is more than the buoyant force, so the net force is still down. So that's the apparent weight you feel. Which way would normal force though act? Up. Okay, the normal force, you would get a positive answer if you solve for normal force. It's the context that's important here. The context. I'll leave you to calculate that. If somebody has it, you can tell me right now, but if not, it's no rush. Other questions? Some other stuff besides fluid mechanics, or another fluid mechanics if you have a question on that, or something else from earlier in the year.
Is like potential kinetic energy?
Absolutely. Energy, that entire section on energy, work kinetic energy theorem, all that stuff. It's first semester stuff. Remember, 25% first semester, 75 second. But anything with the first semester is fair game.
Could you do something to that potential?
Sure. Yep. What do you get as a number?
Negative 15.9.
So negative 15.9 if I rounded, would it round to?
What percentage of the test do you think will be first semester?
25.
Thank you. I just said it like 7 seconds ago. Sorry. So here's the format of the test. Well, I was going to do this tomorrow, I guess, but do you want to know this now?
Yeah.
It doesn't really matter when, I guess. Remind me tomorrow if I start doing this again, not to do it twice. Format is going to be 35 multiple choice worth a point each.
It's 30.
I know, I changed it. Is that on the exam review sheet? I know. I changed it that day. I'll explain why in a minute. That'll be worth a point each, so it's 35 points. So it's a third of the test right there. Short answer, you're going to have 12 questions worth a total of 25 points. The reason I put more multiple choice and a few less short answer, last year some people ran out of time, they claimed. So I thought, all right, you know what I'll do is I'll just add a few multiple choice, but take out the short answer. Multiple choice are quicker, you circle the answer quick, it's a little bit easier. And then the last part will remain the way it was. What did I put in the last part?
6 of 8.
Yeah, choose 6 of 8. Okay, you'll be given 8 questions, you choose 6 of them.
1 minute.
I'll grade those 6, that'll worth 36 points. And then there'll be a 4-point question that's mandatory that you have to add, that adds up to 40 points. So 40 points for math, 25 for short answer and 35 for multiple choice. It's about the same as every test has been this year. Trying to keep it proportional to what you're used to. You
35 and two
percentage, yes, proportional. I don't know. If I say 25, 75, it should be 2 from first semester, 6 from second semester. Guys, I told you it was 25% first semester, 75 second. So, without even looking at the exam, I'm assuming 2 of the last 8 are first semester, the other 6 are second semester.
So we don't even need to do first.
Assuming that works out exactly right. I may have, Jack, this is general for the whole exam. So I may have done 3 first semester and 5 second, and then I may have done fewer first semester stuff on multiple choice. So it's all proportional to the whole points. So 25 points of the exam you could expect to be first semester. Whether that's all in math, or all in short answer, or all in multiple choice, it could be any of those.
What math is most likely to be on?
I'll tell you that tomorrow. Okay, I want to finalize it today, to be honest, that's why. I change my exam every year. Not much, but enough to change it. So I want to take a look and see, because last year I focused on some stuff, this year I didn't. There are topics we went over this year that I didn't go over last year, so I have to tweak that still. Other questions?
Let's get to the second test.
Let's do energy stuff with Kian, yeah. It's Wednesday.
I don't really have a.
It was like all linked together, wasn't it? I don't know if it was an energy or it was like.
It was all linked together?
And then there was like a question that asked like everything.
I mean, there's a few that could be that. It depends. Like, you could have a problem with energy and projectile motion and circular motion all in the same problem. But I'm probably not going to do super complex problems on the final. Yeah. If you go on next year and you say you move up to AP next year for physics and you do the work to get there, those kind of questions, those are like AP level questions where you have an object going off a ramp with friction, starts projectile motion, catches like on a rope, then it's in circular motion, and then the object is charged and enters a magnetic field and it moves. Like all those topics in one. Because I mean, in real life, it's never just one topic. We just, we focus on one. All right, so let's look at energy here. Who's out today? Just Summer? So please, somebody make sure that she watches the video from today, from this review. So at least she has the format there.
What chapter?
What was energy, guys? 5 or 6? 5? Yeah. So in the chapter on energy, we looked at kinetic energy, we looked at potential energy, we looked at spring energy, which was PES, potential energy in a spring, and then we looked at conservation. Conservation tied them all together. We can do one simple conservation problem to represent all of them right now.
Okay.
Let's do that.
All right.
So what kind of a problem is this here? What do we have?
The spring and the projectile motion.
Yeah. Okay.
Double header.
Now, on the exam, you may be tempted to consider using projectile motion equations. But when you have an example where you can look at energy, energy is the easier route to take. Now, you need to know some values. So first, let's say that the initial height of this is 15 meters. Let's say the spring is compressed. Compressed a half a meter. That's an R, not an M. Let's say the spring constant is 200 newtons per meter. By the way, you should know what that means physically. It means it takes 200 newtons of force to compress the spring 1 meter. All right? Remember what K means. The spring constant, 200 newtons per meter. It means it would take 200 newtons of force to compress the spring by a full meter. So since this one is compressed by a half meter, it means that 100 newtons of force is being applied to the spring, and then the object is going to be let go or released. It's going to launch off.
Is K constant?
K is your spring constant, yes. It depends on the material itself. It's given in the problem, but it's usually called the spring stiffness, or the spring constant, or the spring rigidity. Any of those words is fine. Okay? So right away, since the spring constant is 200, the compression is 0.5, the height is 15 meters, We want to determine the impact velocity with which it hits the ground. So how are we going to approach this kind of a problem? This is putting all of them together. It involves kinetic, potential, and potential spring. I'll give you that hint at least.
Can you just label where P
Yeah.
and K is?
What do you got in the beginning, Jack?
P is at the spring.
P in the spring to start. What else?
Oh, there's P. There's another P there.
Good, for the height.
Yeah.
And then?
There's a K at the bottom.
Very good. Everybody see that? That's all we have in this problem. It's starting at a cliff, so it's got some gravitational energy, that's PE. The spring is compressed, so it's got some spring energy, that's PES. It's landing with velocity on ground level. Since it's landing on ground level, it's got no potential down there. Since it's not compressing a spring, it's got no spring at the bottom, it's only got kinetic energy. Remember, this is the instant before it hits the ground. Impact velocity is the velocity the instant before it hits the ground. If you give zero an answer for one of these, I'm going to give her a set. Okay? I've seen that early in the year, but you know better by now. Zero is not ever the impact velocity. Ever. It's never zero. You have to land with some velocity. It can't be zero. It's absolutely impossible. Okay? Unless you had like a helicopter that was lowering it down. Even then, it still touches down with some velocity. It has to have velocity. Okay? It can't have zero velocity. So let's find VF. We do that by looking at our conservation of energy. Conservation of energy tells me MEI equals MEF. Energy before equals energy after. The energy before the process has begun is what kind of energy in the beginning? And?
PES.
Okay, so that's what's happening before this object gets launched off the cliff. And then at the end is when it's about to finish the problem where it hits the ground, and that clearly is KE. At this point, all we have to do is plug in some formulas. Now, you would probably need the mass also. Let's say the mass of this object was 10 kilograms. Sometimes the mass cancels. Why won't the mass cancel in this equation? Who can see this? Let's see who knows what they're doing. Why won't the mass cancel?
Because it's not in PES.
Yes, that's exactly it. PES is 1/2 kx squared. So there's no mass involved there. PE energy, or PE gravitational is mgy or mgh. I use h or y in here. I think I used y. And the kinetic energy is 1/2 mv squared. Now, again, recognize the fact that if mass was in everything, our answer would be independent of the mass. It doesn't matter, because it cancels out. What if this object, instead of being launched with a spring, right, was kicked off the roof or cliff? Whatever. Dirks is a goalie, and he decides to pump the ball. He gives us some initial velocity. So what kind of energy would change in this problem if instead of, again, being launched from a spring, somebody kicks it off the cliff?
The force of the leg, of the kick.
Mm-hmm. But what kind of energy would that be giving you then? Kinetic. Okay, so again, if I were kicking this ball off the cliff, you would get rid of the spring energy, and you'd have KE initial, and then you'd have to call this initial and call that final, and you'd have to give subscripts. So if I kick the ball off the cliff, I would have an initial velocity, so I should give this a subscript of VF. But right now it doesn't matter, because it's the only velocity involved in the problem. But are we clear with that? Okay, again, you could have kinetic before and after. You could have potential before and potential after. What if it goes off a cliff and lands on like a ledge, and it's not at ground level still? Well, then it has potential to start, and still has potential at the end. So you have potential on both sides. But you have to then call them initial and final. I'm going to call this initial for Y and final for VF. So I put the little subscript here and here, although it doesn't matter for this problem because of the nature of the problem itself. Now, at this point, our goal is to find out what the velocity is. So let's solve for VF. Multiply by 2 and divide by m. Multiplying by 2 and dividing by m gives us VF squared. How do I get rid of the squared?
Square root it.
So there's our answer. Okay, at this point in the year, you better be good enough to do this algebraically. You don't have to, but if it is a problem where the mass has to cancel, you need to see that cancellation. You can't plug in for it. Now, you can distribute the 2 if you'd like to. You're more than welcome to. And then the 2 would be in front of the mgyi, and the 2 and the 1/2 would cancel. And then you could technically cancel this mass, but this mass would still be in the denominator of the kx squared. So at this point, honestly, there's no need to simplify. Just plug in the numbers now, because you have an expression for your answer for final velocity. The other type of energy that we looked at, or the other type of energy, the work done on an object is equal to the change in kinetic energy. And the work done on an object is force times distance times, did I tell you cosine theta? Good. I always forget, because sometimes I'll change up the expression from one year to the next to see which works better. Change in kinetic energy means final minus, so you would just have this. Final minus initial. At this point, it depends on the problem. If you're told that the force that's slowing this object down is from friction, replace F with mu Fn. Maybe it's the friction between 2 objects that's slowing it down, so that the final velocity is less than the initial. Is this for real right now? You gotta be kidding. So you would have to replace F if it was friction with mu Fn. Or maybe it wasn't friction. Maybe there's a force being applied just to plug a number in. Maybe it's gravity that's pulling it toward the object, which is changing its kinetic energy. Oh, thank you. So we have to replace the gravitational force maybe with gm1 m2 over r squared. It depends on the problem, the nature of it. Okay? Other questions? Other conceptual, because we have another 2 minutes or so. So I have to put your grades in still. I haven't put your egg drop or your last test on the computer.
Okay.
So how about this? Tomorrow? During class tomorrow, remind me, because I'll put them in tonight. And then tomorrow during class, I can show you the 4th quarter averages only. It won't be the full year, obviously. Other questions? Your grades are done for the quarter, really. I mean, the only thing you can do if you want to do the hand, you get extra credit, you can do that stuff. It's fine. And if you're going to do that, do it tonight. Because I got to put your test grades, and I got to put your egg drop grades still on that way. So I can't give you average this minute. Tomorrow I'll give it to you for sure. It's only the last 2 hours. The hot, cold water thing? Somebody explain to her.
You put your hand in really ice cold water, and you put your hand in warm water,
So,
and you,
I was
at the same time
gonna,
you put your
you
hands
showing us the grades tomorrow.
Yeah, I'll give you 4th quarter grades tomorrow. Just because I don't have enough time. We have about a minute left.
is there a way we could see like what test you did work on, so we could look at it and once it's that?
Sure,
I'm gonna get
absolutely.
it come tomorrow.
Or just email me, depending on if you want to. Like,
Maybe what's not
if you want to email me and say like, what are all my test grades? I can send you your test grades to you. Okay. Sure. I mean, if you look honestly, if you look at the review, if you look at the videos from the year, wherever a review video pops up, everything before that is on that test. So when you see like test 5 review video, all the videos that showed up before that, before test 4 review video, are on that test. So you can see what's on every test.
No, I know, I just want to see, like, because I always do a quick motion.
Oh, did you see the test? Sure, absolutely. Let me know. Just email me. Let me know ahead of time so I'm more available. I can't hear you. I'm not going to keep your test. I'm going to keep all your tests. It's not about you guys, it's about in general. What's happening more and more is the science form we notice is that kids are not studying properly, they're passing out tests and then memorizing answers. So we're trying to change our tests a lot, and at the same time we're just not turning them back. In college, most persons don't turn back the tests. Yeah, a lot, especially in math and science. Engineering, we never got to keep our tests. I'm not going to do the blank test. Because then you could all download them and then if you want to come in and look at your tests and see what you need to focus on, I'm happy to do it. If I'm here and you want to look at them and go over them, sure.
Yeah.
Tomorrow? Only during free. I'm not going to be able to anymore. I'm not here on Tuesday.
Oh.
No, next week.
Why?
I'm only here on Wednesday. We proctor on the tests of the days of our tests. I proctor next week on Wednesday and Friday. If you have a question, hey guys, listen. If you have a question after tomorrow over the weekend, just send me an email and I can even record a quick video with an explanation and send you a link to it.
Oh, that's
It's really simple to do that. Again, because guys, remember your test is Wednesday. I'm not in on Tuesday. I'm in on Wednesday and Friday next week. Okay, so if you have a question from tomorrow after class until Tuesday, send me an email. I'm happy to send you an example of something, or maybe I'll send you a link to a video I create. Okay?
This is more.